Hi, geometries. All right, for this triangle folding, I again have a right triangle. I again have an acute triangle, and I again have an obtuse triangle. Our green triangles are going to be our perpendicular bisectors. Okay, so the really cool thing about the perpendicular bisectors are I know that they are created from the midpoint of the side, but they are also going to be perpendicular. So when I take each side of a triangle and I fold it in half, what I get automatically is the segment that is the perpendicular bisector of that triangle. And I know that this is the midpoint because I folded it. And I know that this is a right angle because of how I folded it. And of course I can test it with my post-it note to prove that it is in fact a right angle. So each time I fold a triangle side in half, instead of just pinching at the midpoint like we did for the mid segments, we're going to go ahead and fold it because that segment here is going to be a bisector and it's going to be perpendicular because of the fold. So the interesting thing about a right triangle is the perpendicular bisectors meet on the hypotenuse. Now it's crazy to think about, but as I fold each of the three sides, we can see this point of concurrency. I can see this perpendicular bisector where I folded each of my triangle sides in half, and that fold is creating a point of concurrency. This point of concurrency for our perpendicular bisectors is called my circumcenter. And the circumcenter is going to be equidistant to all three vertices because my perpendicular bisector is equidistant to all three endpoints of the line segments. So here it is for my right triangle. Let's see what happens with the acute triangle. For a right triangle, the point of concurrency was on the hypotenuse. For an acute triangle, I'm going to fold each side of the triangle in half and trace the line that is created on the fold. This is my midpoint. That's my perpendicular bisector. Here's my midpoint, and here is my perpendicular bisector. Midpoint, perpendicular bisector. So I folded this edge, I folded this edge, now I'm going to fold this last edge, and this is the holy cow wow part of this story, is how amazing is that these three lines are concurrent. Each of these lines goes through this point of concurrency. Each of three lines is made from the midpoint of the angle side. Each of these three lines is perpendicular to the side opposite. This point here of an acute triangle for my perpendicular bisectors intersects at this point of concurrency that we call the circumcenter. The circumcenter is equidistant from each of my vertices. This point is the same distance to here as it is to here, as to here. And that's what's really crazy. With the right triangle, these distances were along the sides. With the right triangle, this distance here, of course, is going to be the same because it's along that hypotenuse, because my circumcenter is on the right triangle. And that distance is also going to match this distance here. When we look at the acute triangle, this point is going to be equidistant to each vertex. Equidistant to here. Now think about that perpendicular bisector theorem that we had before. We know that any point on the perpendicular bisector is equidistant to the endpoints of the segments. So this is not surprising. Each of these dotted lines is going to have the same distance from this point that's on the perpendicular bisector to the endpoints of the segment. Let's check out what happens with an obtuse triangle. It's a little bit different. When I go to fold my obtuse triangle sides and get my 3 perpendicular bisectors, you're going to notice something a little bit different for our obtuse triangle. And that is, you won't see a point of concurrency. It's there, but it's not on the triangle. So this perpendicular bisector, this perpendicular bisector, and this perpendicular bisector, they do not meet inside of the triangle. If you were to continue each of these lines here and here and here outside of the triangle, you can see where they would meet. So we'll get a piece of paper and show you what that's going to look like. So if I had my triangle here, if I were to continue each of these perpendicular bisectors, yes, they still meet at a point of concurrency, but for an obtuse triangle, it's going to be outside of the triangle. And here is our point of concurrency, which is our circumcenter. For an acute triangle, the circumcenter is inside. For a right triangle, the circumcenter is on the hypotenuse. And for an obtuse triangle, that circumcenter is outside of the triangle. But guess what? It's still going to be the same distance, equidistant to each vertex. So each of these pink lines that I am drawing is going to have the same distance from the vertex. Same distance from this circumcenter to the end point of each segment, each side of the triangle.